Sai, can you make it? Can you make it full screen more?
Yes, sir. Like, I'll present it again. I'll only present a screen.
Okay.
Now is it visible, sir?
Yeah, it is visible. So you loaded with the AX register.
Like first I loaded AL with 00, sir.
Okay,
And
AX
then
is
BL with 00.
okay.
On multiplying mul BL, it will store in AX.
Yeah.
So I just copied it from AX to CX just to store the output.
Okay.
And then I use LAHF, sir.
Mm-hmm.
So it will, the flag content will be stored in AH register.
Yeah.
And that is showing 42.
4200. I will check it and I will try to find out the answer.
Okay.
Yeah. So yes, I told you this is the first time I am learning this subject also. I have to, so it will take time. I will try to answer your question next class result.
So like one more thing, since
Yeah.
for division there's no change in flag bit in today's assignment, for 8-bit we can use flag register only for addition, subtraction and multiplication.
Yeah, only one time only that in the first class, just for showing the flag register, using 8-bit addition or addition or subtraction, we use the flag register. That you can consider as a as a separate experiment or a part of the experiment, something like that. Say, if you are considering it as an separate experiment, that you can consider as a separate experiment. Then 18-bit, 8-bit multiplication, addition, those things are separate experiment, and the remaining last we did division and multiplication. Yeah, that way you can consider as a 3 experiment or a part of first experiment, 1A, 1B, 1C also. In second and third, there is no need to show the flag register, this register contents.
For multiplication division, sir?
Yeah, multiplication and division, there is no need to show in the result, there is no need to show. But thing is, just check what is happening. And anyway, right now everyone have some confusion. Even I have also confusion regarding that how it is getting affected. That we will check it, and I will explain what is actually happening.
Okay, sir.
Okay.
Thank you, sir.
Yeah, right now there is no need to show in the result. There is no need to show the what is happening to these registers. Only result is enough. Okay, that PhD scholar will join soon. Not time.
Sir?
Nagaraj.
Yes, sir. Yes, sir. Sorry.
Yeah, no issue, no issue.
Hello, Nara sir.
Sir, am I audible?
Yes, sir, you're audible.
Yeah, you are audible.
Sir, now we need to do code conversion, sir.
Code conversion.
Shall I share my screen, sir?
Pardon me?
Shall I share my screen and explain the code?
Yeah, you can directly explain the code.
Okay, sir.
For which experiment it is doing, that also just, I mean, if it is a binary to some other conversion, that also you can explain.
Okay. Only the code and the output, sir.
Yeah, that is enough.
Okay, sir. Uh, Students, second experiment is code conversion. So in that code conversion, we have 4 type of conversion. So first one is binary to gray. Sir, it is difficult to write here. Okay. 4 type of code conversions are there. First one is binary to gray to binary, and third one is decimal to hexadecimal. Fourth one is hexadecimal to decimal. Okay. So first we need to see how to perform how to convert a decimal number to hexadecimal number. How to convert a decimal number to hexadecimal number. Sir, my screen is visible, right, sir? Srinivasan, sir?
Yes, sir. Yes, sir.
Okay, okay. So we need to
Sir,
convert.
sir, Nagaraj sir.
Yes.
So can you share the PPT in that one marker will be there, sir, so that you can write and you can explain. You take that one PPT. Any PPT you can take and share it. Share that below. You will get the marker, sir.
Okay, okay, okay. I understood.
Then you can write.
So see, 4 type of code conversions will be there. First one is decimal to hexadecimal. Second is hexadecimal to decimal. Third, binary to gray. Fourth, gray to binary. This will be the 4 code conversion we need to see. First one is decimal to hexadecimal. So if you take decimal to hexadecimal, okay, so we are planning to convert a decimal number. Okay, we are planning to convert a decimal number to hexadecimal number. Similarly, if you take hexadecimal to decimal, means first we need to take hexadecimal number and we need to perform a decimal conversion, hexadecimal to decimal conversion. Okay, so first one is decimal to hexadecimal conversion. So in decimal to hexadecimal conversion, we need to take any decimal number. Okay, we need to take any decimal number. For example, I am taking 58. Okay, 58. Okay, and we need to convert into an hexadecimal number. Okay, so how to perform that decimal to hexadecimal conversion means, first we need to split this 58, okay, into these two kind. first we need to split into ones and tens, hundreds and thousand parts. So here ones place is 8 and tens place is 5. So that we need to split that into 5 and 8 separately. Okay, we need to split into 0, 5 and 0, 8, and then we need to multiply this tens place by 0a, and we need to add the ones place. You will get a hexadecimal number, okay, which is 3a. So this is a procedure of converting a decimal number to hexadecimal number. Okay, so see, if you take a decimal number, the decimal number is 58 or 8-bit decimal number. Keep in mind it is 8-bit decimal number. Okay, it should start from 00. It start from 0 to 99. Okay, so my program written for converting only 8-bit decimal number to corresponding hexadecimal number. So first one is, if you take any number in between 0 to 99, for my example I am taken that number 58. Okay, so how you convert that decimal number to hexadecimal number? First we need to split the places. There is a ones place, tens place and hundreds place. So ones place is 8 and tens place is 5, right? So we need to split that into two parts and save it into two different registers, and then we need to multiply that tens place with 0a, okay, in order to convert into hexadecimal number, plus we need to add that ones place. You will get 3a. So the conversion of 58 decimal number to hexadecimal number is 3a. Okay, so in my program, okay, some logical operations will be there. Some logical operation, for example, AND operation and XOR operations will be there. Okay, so I like to explain how to perform that AND operation and XOR operation. For example, if you are going to perform, okay, if you're going to perform AND operation between these two data, 5, for example, 58 with 0f. Okay, what you will get? For example, 58 means it is 0, 1, 0, 1, and 8 is 1, 0, 0, 0. Similarly, 0f is 0, 0, 0, 0, and f is 1, 1, 1, 1. So if you perform AND operation means it is 0, 0, 0, 1. So 1 into 0 is 0, 0, 0, 0. So the higher, the 4-bit nibble, this nibble becomes 0 and this will becomes 8. Okay, so if you perform AND operation, that is AND operation of that particular input with 0f, you will get this number 08. That is, you are getting ones digit. Okay, ones digit. And similarly, if you perform AND operation between 58 with F0, okay, you will get 50. You will get 0. That is tens place. But the difference between this and this one is, okay, we need to shift the bits. Okay, we need to shift. So 50, in order to get 05 from 50, we need to shift the bit. Okay, so for that I am using SHR. Okay, shift that bit. For SHR means shift right. Okay, SH shift R means right. 50, for example, how you write 50 in a hexadecimal number? It is 0, 1, 0, 1. Okay, so this will be 0, 0, 0, 0. Okay, if you perform shift by 4 times, okay, shift 4 times means you will, for first time you will get, okay, you will get 0, 0, 1, 0, 1, 0, 0, 0. and second time you will get 0 0 0 1 0 1 0 0. Third time 0 0 0 0 1 0 1 0, and fourth time you will get 0 0 0 0 0 1 0 1. Okay, so after performing 4 times right shift, you will end up with 5 0 will end up with 0 5. Okay, then we need to multiply with 0 5 into 0 a, and we are just perform 0a, and we are performing 0 we are adding 0.8 to that result. You will end up with hexadecimal value 3a. Okay, so this is my program explanation. Okay, so this is my code, okay, which converts a decimal number to hexadecimal number. Okay, so this is my starting segment. Okay, my program starts with 1000H. Okay, so SI comma 8500. Move SI comma 8500 means we are initializing SI with 8500, and move AL comma within a bracket of SI means we are moving the content of SI to AL, okay, which is nothing but 8-bit decimal number. 8-bit decimal number. Since the moving operation involves only 8-bit, we are moving the content of that 8500 to AL, which is nothing but 8-bit decimal number. And we are moving the same content, okay, whatever we are getting from 8500, so same content is to be moved to BL also. Okay, then we are performing AND operation with the same content. For example, 58. Okay, 58 is my input, means I am performing AND operation of 58 with 0f. Okay, you will get 08 as a result. Okay, it will be stored in BL. Okay, and again AND operation of AL. AND operation of AL with F0. AND operation of AL with F0 means 58 with F0. You will get 50. Okay, so up to this, BL contains 08 and AL contained 50. Then move CL comma 04. Okay, just a data transfer operation. Now the CL contained 04. Contains 04. Then we need to move the content of DL. So we need to move the content of 0A to the DL. Okay, and DL is equal to 0A then, and SHR. So I already explained. So what is the purpose of SHR? In order to get 05 from 50. So for that only, so I already mentioned AL contain 50, right? So 50, we are moving the content of AL 4 times in order to get 50 to 05. Is it clear? So initially AL contains 50. Okay, CL contains 04. Okay, so SHR AL comma CL means CL is 4, right? So we are moving the content of, we are shifting the content of AL 4 times to get that value. Okay, so initially AL contains 50, it will become 05 then. Okay, then we are multiplying 05. Okay, DL is nothing but defaultly it will multiply the content of DL with AL. Okay, you know that AL will contain 05, and then DL will contains 0A. So 05 into 0A. Okay, and result stores in AL. Okay, and we are performing addition operation, that is AL plus BL. So AL now contains 05 into 0A plus 08. The results again stores in AL. So in order to save the result, we are incrementing that SI register, which is 8500 to 8501. So, and we are moving the content of that register, that is AX register, to SI. So this will be the end result. This will be the ending statements. Okay, so this program will get 8-bit decimal number, okay, and it will convert into one hexadecimal number. So that is a main this program. It will get 8-bit number, 8-bit decimal number, and that 8-bit number is converted into one hexadecimal number. Okay, I will show the results now. Masm bh.asm. So I am not getting any errors. Then link bh.obj object file. So no stack segment. Okay, this is also runs good. Okay, then debug bh.exe. Then we are giving a value. For example, in 8500, first value is 58. Okay, so this is your input. Okay, this is your input. 58. 58 is a decimal number, 8-bit decimal number. Okay, then we are going to run the program and we need to see the results now. So the input is in 8500, the input is 58. Okay, the output is 3A. Okay, so 3A00. This will be the output. Okay, 58 is your decimal number, and 3A is your hexadecimal number. So conversion of 58, it becomes 3A. Okay, let me give one more example. E8500, for example, I am giving A2, sorry, decimal number, right? So decimal number means 99. Okay, 99 is a decimal number. I'm going to give now. Then G equal to 1000. Sorry. G equal to 1000 and C now. So 99 is a decimal number, that is 8-bit decimal number. The conversion of this decimal number to hexadecimal gives 63. Okay, so if you have a calculator, please check that in calculator. So the conversion of 99 decimal number to hexadecimal is 63, and similarly the conversion of 58 decimal to hexadecimal is 3A. Okay, so I will share the code in a chat box. Use that one. So I shared the code, please use that one. So this is a program of converting 8-bit decimal number to the corresponding hexadecimal number. So you should give only 8-bit, okay, 0 to 99, okay, that too in 8500, only one memory space. Okay, so 8501 and 8502 contains the output hexadecimal number. So that is, keep in mind, only 3 memory places are involved. 8500 contains 8-bit number, a decimal number, and 8501 and 8502 is a hexadecimal number. That's all. If you have any doubts, please ask me.
Nagaraj,
Yes,
let me present something. The same thing, just
Yes, sir.
yeah. Instead of using the calculator directly, we will show how to perform this decimal to hexadecimal conversion.
Okay, sir. I stopped sharing, sir.
Yeah, good. So basically, he used two examples. I will take the same example, so you will get the answer. So this is 58. This is a decimal number. Decimal number, as you know that decimal numbers, its numbers, its mnemonics is starting from 0 to 9. So all the numbers are in decimal number we are giving. We have to convert this decimal number into hexadecimal. So a decimal number can be converted into hexadecimal by dividing with 16. So this is 3 into 16, 48. Remainder is 10. So that 10 can be expressed as in hexadecimal. That 10 is expressed as A. So the result is 3A. So that is what we have seen in the result. Okay. Or if you are using calculator also, your conversion is in the same process. So when you are converting that 99, this 99 is a decimal number. So we can divide it by 16 for converting into hexadecimal. So converting into hexadecimal, this is 6 into 16, 96. So remainder is 3. That 3 is coming here. So 63 is coming. Okay. So I hope that this conversion process you remember. And here what he did is he split this numbers into two parts. This is 10th decimal position and this the last decimal position. And he multiplied this with the 10. Then so we can see that operation also. So this 58, what he did is he split into two parts. This 5 into 5 and 8. He multiplied this 0, 5 into A, that is multiplied with the 10. So he multiplied with the A. Then he added the last value, that is 0, that is 8. Okay, so 0, 5 into A. So we can convert those who are forget about this hexadecimal multiplication. You can always perform this operation in the binary format. So 0, 5 into A. So 0, 5 is in hex binary is represented by 0 is represented by 40. Then 5 is represented by 0, 1, 0, 1 multiplied with the 0A. So 0 is 0, 0, 0, 0 and A is 1, 0, 1, 0. Then the multiplication is bit by bit multiplication. So you multiply this 0 with all the bits, it will get 0, 0, 0, 0. 0, 0, 0. Then multiply this with this one. 1 into 1, 1, 1 into 0, 1 into 1, 1 into 0. Then all are zeros. Okay. Similarly, continue this operation. And again 1, 0, 1. So it is coming 1, 0, 1, 0, 0, 0, 0, 1, 2, 3, 4, 5, 1 more 0, 2, 3, 4, 5, 6, 7. Okay. Yeah. And 1, 2, 3, 4. Then again 4 more zeros. You have to multiply this with all the zeros. So 0, 0, 0, 0, 0, 0, 0, 0, and so on. So finally, again 0, 0, 0, 0, 0. And finally, if you are adding, you will get this answer. This 0 into 5 multiplication you at the result side is something like this: 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. Then 0, 0. Let me write it one more time. Last is 0. Then again 1 will come. Then again 2 more zeros will come. Then 1, 1. Then remaining all are zeros. So just do it formally, then you will get. So this is represented in hexadecimal as 32. So this is 2 and this is 3 hexadecimal. So 32 is the answer you are getting when you are multiplying this 0, 5 into A. Then you are adding that 8. So 32 plus 8. So that is hexadecimal. This is also hexadecimal. 8 plus 1, 9. 8 plus 2 is 10. That is represented by A. So 3A. You will get 3A as the answer. And in this program, he used the logic. He want to he used the AND operation to split it into two parts, and in order to shift convert that to 50. When he multiplied with the AND operation, he got 50, and in order to convert that 50 into 05, he used that shift to right by 4 times. So this generally this SHR operation is something like this: SHR register, comma 1. So this means it will rotate towards the right by 1 unit. And if you want to rotate it by multiple bit position, then default ways CL is the register that is using. So that is why he used that CL, and he loaded that CL initially with the 4. That means he need to rotate it by 4 positions, 4 times. That is why he loaded in the program. It is mentioned that 4 times it is rotating. So it is rotated towards the right side by 4 times.
Hello, Nara sir.
Yes, sir.
So, stop lighting.
I think we need to give some time for executing the program, sir. Students will ask for.
Yeah, we can wait for some more time, and maybe after some time we can explain the second program also, and then maybe by that time, let me check it if power. Actually, here power cut is power is not there. Yeah, anyway, we can wait for some more time, and if students have some doubts, we can clarify that.
Okay, sir.